In this video, we are going to discuss question 7.30. The question says, an 83 kilogram running back leaps straight ahead towards the end zone with a speed of 6.50 meter per second. A 115 kilogram linebacker, keeping his feet on the ground, catches the running back and applies a force of 900 Newton in the opposite direction for 0.750 seconds before the running back's feet touch the ground. Part A of the question is asking you, what is the impulse that the linebacker imparts to the running back? Let us first sketch the question. You have a running back that leaps in the forward direction, that jumps forward with a speed of 6.50 meter per second. So I will write down the speed of the running back as VR, which is 6.50 meter per second. His mass of the running back is 83.0 kilogram. And he leaps forward and is caught by a linebacker. The linebacker exerts a force on the running back in the opposite direction. So the force by the linebacker is in the opposite direction. Mass of the linebacker, I will write mass of the linebacker as ML. L for linebacker is 115 kilogram. And he is applying a force of 900 Newton for a time period of 0.750 seconds. Part A of the question wants me to find what is the impulse that the linebacker imparts to the running back. The linebacker is applying a force of 900 Newton on the running back, and that is for a time period of 0.750 seconds. We know that impulse is equal to force into time. Now, this force that the linebacker applies on the running back is in the opposite direction to the running back's velocity. And since it is in opposite direction to his velocity, I will take this force to be negative. So we can calculate the impulse as negative 900 times the time, which is 0.750. And when you solve this, you get your impulse as negative 675 Newton second. So this impulse exerted by the linebacker is opposite to the direction of running back's velocity. Part B of the question is asking you, what change in the running back's momentum does the impulse produce? So here we need to find the change in momentum of the running back. We know from impulse momentum theorem, impulse is equal to change in momentum. So this was the impulse imparted by the linebacker on the running back. And this impulse is equal to the change in momentum of the running back. So I will write the same value. Change in momentum is equal to impulse, which we calculated as negative 675 Newton seconds. Now, generally, we write momentum in the unit of kg meter per second. But from impulse momentum theorem, since momentum, the change in momentum is equal to impulse, and impulse can be written with the unit of Newton seconds. Here I have written change in momentum also as Newton seconds. Again, this change in momentum will be opposite to the running back's velocity. Part C of the question is asking you, what is the running back's momentum when his feet touch the ground? Again, we are going to use impulse momentum theorem to find this. Question is asking me what is the running back's momentum when his feet touch the ground. So when he is obstructed by the linebacker, when he is stopped by the linebacker, what will be his momentum when his feet touch the ground? We know from impulse momentum theorem, impulse is equal to change in momentum. So we can write impulse as final momentum minus initial momentum. And I can calculate my final momentum by rearranging the term. P final will be J plus P initial. I will just move P initial on the other side of the equation. Minus will become plus. P initial can be written as mass times the initial velocity of the running back. So let's substitute. We already know the impulse, negative 675. Mass of the running back is 83 and his velocity is 6.50. And when you calculate this, you get the final momentum of the running back as negative 135.5 kg meter per second. The last part of the question is asking me if the linebacker keeps applying the same force after the running back's feet have touched the ground, is this still the only force acting to change the running back's momentum? So after the running back's feet touch the ground, is the force of linebacker the only force acting on running back? The answer to this question will be no, because the moment the running back's feet touch the ground, there will be a force of friction between the ground and his feet. So the moment his feet touch the ground, friction force comes into play. So it will not only be the force from the linebacker, it will be force from the linebacker plus the friction force acting on the running back. So your answer should be no. Linebacker's force is not the only force acting on the running back. The moment his feet touch the ground, there will be a force of friction acting on him too.